Welcome to Study Loop.
So in this problem, what we have to do is first you have to find out the balanced equation for each reaction given, and from there we will have to find out the overall ionic equation based on the solubility of the substances or the compounds which is present in each reaction, and from there we'll have to find out the net ionic equation for each reaction. So here is our first reaction, which is between the Na2CO4 and NH4 to C2O4. So the products will be Na2C2O4 and NH4 to CrO4, and the information based on which we are writing all of these are aqueous is based on their solubility in aqueous solution. So if we look at the solubility chart, which is provided also in the book, we will see that all the sodium and the NH4 compounds are usually soluble in water. And also, from the result condition of this reaction, we are given that no precipitate was formed in this reaction. That means all the compounds present in the reaction mixture are in aqueous, and there is no solid which is formed as the precipitate in this reaction. That's why this is our balanced reaction equation, and from here we can write down the overall ionic equation, which will be 2Na plus CrO4 2 minus, all are aqueous, plus 2NH4 plus C2O4 2 minus, and all will give us 2Na plus aqueous plus C2O4 2 minus, which is also aqueous, plus NH4 uh, 2NH4 plus aqueous, and CrO4 2 minus aqueous. So this is the overall ionic equation for these reactions, and we know that if we have any solid formed in this reaction, in that case we can just cut out the spectrotrans from both sides of the reaction equation. But since there is no solid formed and there is no precipitate, that means this overall ionic equation is the net ionic equation for this reaction also. So this is our net ionic equation for this reaction. Now we'll go to our second one, where Na2CrO4 is reacting with AgNO3 to form NaNO3 and Ag2CrO4. So in the result condition for this, we are said that there is a red uh, solid, or the red precipitate is formed. So which one of these two compounds are precipitate? We can identify them by the solubility of at least one. Since we don't know the solubility of CrO4 from the solubility chart, but we know that all the nitrates are soluble in water, and also all the alkali metal compounds are soluble in water. That means obviously this is soluble in water, and that's why the other compound, which is the Ag2CrO4, will be our solid precipitate um, formed in this reaction. So this is our precipitate Ag2CrO4, and that's why we have written it in the solid form. So now, for writing the net ionic equation in a reaction which has a solid precipitate, what we have to do is we can ignore the compounds or the ions which are in aqueous condition in both sides of the reaction equation. So from here we can see that since the sodium and nitrate is in aqueous in both sides of the reaction, that means these are our spectator ions in this reaction equation, and we can just omit them, and we can write down the net ionic equation just by writing the ionic equation for CrO4 minus and Ag plus, which are forming a solid uh, compound in this reaction. So the net ionic equation for this reaction will be CrO4 2 minus aqueous plus uh, 2Ag plus, and this will give us Ag2CrO4 solid. So this is the net ionic equation for this reaction. Now we'll go to our next one. So here what we have is Na2CrO4 is reacting with CaCl2 to produce NaCl and CaCrO4. So from the reaction condition of this one, we are given that a yellow precipitate is formed, and again we will identify which one can be our precipitate here. So from here you can see that sodium chloride is a alkali metal compound, and which is obviously soluble in water. That means this cannot be our solid precipitate. That means the other compound formed CaCrO4 will be the precipitate which is formed as the yellow precipitate. That's why we will write this one as our solid, and this is our solid precipitate which is formed in this reaction. Now again, to write down the balanced equation, we will just ignore omit the ions which are present in aqueous condition on both sides. So from here you can see that sodium and chlorine are present in aqueous condition on both sides, and calcium and CrO4 are reacting to form this CaCrO4 in the precipitate or solid form. So we'll just write down them to find out our net ionic equation. So in the net ionic equation, CrO4 2 minus is reacting with Ca2 plus to give us CaCrO4 in solid form. So this is the net ionic equation for this reaction. Now we'll move to our next problem. So from here we can see that NH4 to C2O4 is reacting with silver nitrate to give us NH4NO3 and Ag2C2O4. And from the reaction condition of this one, we are given that a white precipitate is formed, and again we will identify which one is our precipitate first. So we know that all the nitrate compounds are soluble in water, and also all the ammonium compounds are soluble in water. That means ammonium nitrate is obviously soluble in water, and it cannot be our solid precipitate. That means the other compound formed will be in the solid form, and this will be our precipitate which is formed in this reaction. That means this Ag2CrO4 is our precipitate here, and again we will just write down the net ionic equation by ignoring the ions which are present in aqueous form in both sides of the reaction equation. In this case, these are nitrate and the nitrate and ammonium ion. Nitrate and ammonium, these are present in aqueous in both sides, so we'll just ignore them and write the net ionic equation by writing down the other ions of the compounds. So the net ionic equation will be C2O4 2 minus plus 2Ag plus, which will give us Ag2C2O4 in solid form. So this is the net ionic equation for this reaction. Now we'll go to our next one. So in this case, we have NH4 to C2O4 reacting with CaCl2 to form NH4Cl and CaCl2O4. And once again, in this case, we have another white precipitate. And again, so NH4Cl is a compound of ammonium ion, and which is obviously soluble in water. As we know that almost all the NH4 compounds are soluble in water. That means this cannot be our precipitate. That means obvious choice is CaC2O4, which is our solid precipitate formed in this reaction. So the net ionic equation will be just the reaction of calcium and C2 C2O4 to form the CaC2O4. So the net ionic equation will be C2O4 2 minus plus Ca2 plus to give us CaC2O4 in solid form. So this is the net ionic equation for this reaction. And finally, we have silver nitrate reacting with calcium chloride to produce AgCl and CnO3 2. Again, we have to find out which one is our precipitate here. So as you know that all the nitrate compounds are soluble, that means this is soluble in water and it cannot be our solid precipitate. So the other compound, which is AgCl, is the solid precipitate which is formed. That means the net ionic equation will include only silver and chlorine in the reactant side and HCl from the product side. So the reaction, the net ionic equation will be 2Ag plus 2Cl minus will give us 2AgCl as the solid. So this is the net ionic equation for this reaction. Now, in the second part of this question, we are asked to identify the precipitate formed in each of the experiment, which we have already done, but we'll just recap it. So, in this reaction, our solid precipitate formed is AgCl. Now, in the previous one, our precipitate is, in the fifth reaction, our precipitate is CaC2O4. In the fourth reaction, our precipitate is Ag2C2O4. In our third reaction, our precipitate is CaCrO4. In the second one, our precipitate is Ag2CrO4. And in the first one, we don't have any solid precipitate formed.